My name is Tim Smith. I'm the Senior Manager of Field Engineering and Training at Stonhard. I've been working for Stonhard for 17 years, and today we are going to discuss moisture vapor transmission and how it can affect floor coverings. Moisture vapor transition is when you have a pressure gradient or a difference in humidity below your concrete slab and above. And basically when you have drier air above a concrete slab, that moisture wants to meet equilibrium, so it works its way up through the slab and to the surface. So if you have an older construction where there is no known vapor barrier, so the amount of moisture that can actually, ground moisture that can come through the slab is unlimited, then it can actually be high enough pressure to actually cause blistering or floor failure, delamination. So there are two industry standards when it comes to testing for moisture vapor transmission. One is a calcium chloride test, where you actually have to prep the concrete first, and then you take a little disc of calcium chloride and you put it under a piece of plastic, and you have to let it sit there for 72 hours. And then you see how much moisture it actually absorbed by weighing it beforehand and then weighing it after. And then that gives you an idea of how much moisture is coming through the slab. The more common one that we use now is actually, it's called a rapid RH meter. And basically what you do with that one is you just drill into the concrete 40% of the depth of the concrete. And then you put a probe in there. You let it sit in there for 24 hours. And then you come back and you stick your reader in, and it will give you both the relative humidity, or how much moisture is in the concrete, as well as the temperature. And that's a more accurate, in our opinion, a more accurate and easier way of getting moisture readings in concrete. A lot of times in the industry, when you're trying to let something sit under a plastic container for 72 hours, a lot of times, you'll have other trades or a forklift, and they can actually just knock into that thing and ruin your test. Whereas the RH test is immediate, and it's also in the concrete, so you can always put a little cap on it, and guys can't disturb the type of testing. Absolutely not. Especially if it is a construction that is older construction, probably before mid to late 90s. There's no guarantee that the concrete on grade has a vapor barrier underneath it, because vapor barriers became very, very popular in the mid to late 90s. So if you're talking about a 30 or 40-year-old building, then the amount of moisture that can permeate through the slab will change depending on the seasons. If you're in a dry season and there's not a lot of groundwater, you could have false negative readings. And if it's the rainy season, then you're probably looking at something a little bit more extreme when it comes to pressure. Not always. If it's a brand new construction, new concrete pour, and we know that there's a vapor barrier and we're installing one of our mortar systems, we don't even have to test after 28 days of drying for our epoxies, and usually after 7 to 10 days of drying for our urethane, cementitious urethane mortars. No, they do not. Any type of liquid-rich product will have lower tolerances than a more robust or porous mortar that we're putting over the top. So our mortars, the limits for our mortars for RH is 85%. Anything below that, we're confident it will hold up. But with our liquid-rich products, you're looking at anything below 80% for RH readings. So our territory managers are actually required to contact tech service or samples, and they can get moisture tests sent to them. So we expect them to do the moisture test themselves. If we do find that there's a problem, we have a couple of ways of mitigating it. Our main product is StoneFill OP2, which can handle up to 99% relative humidity, or 15 to 18 pounds per square foot in calcium chloride testing.